from data, if you will, but it's the full life cycle. It's starting with collecting data, understanding data. What's the business problem trying to be solved? It's the full life cycle of preparing data, then analyzing it, perhaps visualization or building a predictive model. And then, storing information and kind of moving forward. So the Venn diagram you can see is a pretty classic description of the skills required. So it's computer science, it's programming, it's statistics from the math perspective. And there's a fair amount of domain knowledge that either the data scientist has, but certainly the data science team has. And then the other kind of key question that I think might be good to cover at the very beginning is data science versus ML, which is machine learning, or AI, artificial intelligence. Some people use them interchangeably. Some people think that they're very different and very clear. So I thought I would provide my perspective on how they relate to each other. And you can see in the Venn diagram here, there's a fair amount of overlap in my perspective. I think what I'm going to talk about is true for all of these types of projects. So data science is really this, as I mentioned before, this end-to-end process for generating actionable insight from data, which is different than a software project where, again, software project is having a team develop a tool or a system that helps optimize or improve something, for example. Machine learning is typically maybe a subset of data science. You can think about it as working on building a predictive model with data. And so sometimes it's not so much understanding the business context. And again, depending, some teams define machine learning pretty much the exact same way data science is, which is the full life cycle. Other groups think of machine learning as maybe the key aspect of the data science project, building a predictive model. And then AI, artificial intelligence, again, some people use them intermixed, and others view AI as being maybe a more holistic system, which maybe has sensors, for example, to collect data. So a self-driving car definitely has machine learning, there's data science, but people will refer to that as an AI system because there are sensors to get where the car is on the road and cameras and whatever case might be. And so again, what I talk about will be how to build predictive models, the challenges of building predictive models. And that's true across data science, machine learning, and AI. Okay, so now that we have a kind of a basic understanding of the field, I want to talk a little bit about why process is so important. And so here are some key stats. There's many others. I could have spent the entire time, quite honestly, talking about statistics that show that there's challenges in teams executing data science projects. So the first one is, the vast majority, 87% of projects never make it to production. And there's some reason why some projects don't make it to production. There's lots of unknowns when people execute data science projects. So the fact that 100% want to make it to production is fair. Expecting some not to make it to production is reasonable, but having 13% only make it to production is obviously not good. And most of the places that I've worked with, that's not really a good success rate. So what's driving some of these issues? And so here are some underlying concerns, if you will, that kind of highlight that things aren't as good as they should be from a process perspective. So working on the wrong problem. So 69%, right? That's a huge percentage of data science team report working on the wrong problem. So fundamentally, if you're working on the wrong problem, nothing else matters. It's just, why were you doing that? And clearly process plays a key part in that, because somehow the data science team thought that they should be working on one thing, and in fact, they should have been working on something else. So clearly there's a communication error. And 62%, you can see that next stat there, 62% of data science teams report having poor communication. And I would say, obviously, it's higher than that, because if 69% working on the wrong problem, then it's at least 69% that are having poor communication. And these are self-reported numbers, so it's probably even worse than that. Both of these numbers probably are higher than this. This is what data science teams currently think. And if we did an audit of data science teams, it would probably be even kind of more pronounced than this. And the last stat that I pulled out here was that roughly 3/4 of teams suffer from challenges in how long tasks take. So task estimation. So, not only a project, but a task. How long it will take, it's hard. And I'll come back to why that's so important for data science projects and why that's so important in terms of defining a process. But clearly that's a key challenge. And you can see that sometimes, these are from last year. The 87% is from a couple of years ago, but there's many, many different surveys and reports. And if you just talk to individual teams, most teams kind of have some sense of these types of challenges. So why do data science projects fail? A bunch of those problems from before really kind of jump out at you, right? So there's other challenges as well. So not having the right data, for example, wasn't highlighted in the previous slide, but it's a key challenge, right? So maybe not having the right data, maybe the data doesn't have predictive value. So if you're trying to build a predictive model and your data has no predictive, actionable insight that can be generated, then it doesn't really matter what your project process is, you're not going to succeed. Solving the wrong problem obviously is an issue. Not deploying value is very much related to solving the wrong problem. When I mentioned here that thinking about deployment is the last step, that's because deployment is a step, but you need to learn from that. You need to adapt. A lot of machine learning models need to be refined over time, for example. You need to kind of understand, is the machine learning model doing predictions that we thought would be useful? Are they actually making predictions that are correct, more or less of the time? We can talk about ethics. There's been lots of different discussions about ethics in data science and the challenges of doing that. And, we can talk about that for a lot. But it's clearly one of the things. And then the culture of the team is important too. And that relates to a little bit about task estimation and how to manage a project where it's difficult to estimate how long tasks will take. I think this is a good time. I'll jump in and take a look at the first question that was posted here, and I'll read it out loud, and then we'll kind of get into it. So in projects, estimation is one of the most difficult tasks. Is this one of the reasons to work through iterations? Do you use accuracy of your estimation? So I think that's a great point, and I'll talk about iterations in a little bit. But at a high level, because estimating things is difficult, we want to estimate small things rather than big things, small tasks, if you will, rather than a whole task. So if I have a 6-month project, my estimation is going to be much less accurate than if I try to estimate something that's going to take, roughly a week plus or minus something. And so we use iterations to try to minimize the risk, and we'll talk about that, but that's a great point and great question. So what are some of the signs of a poor process? And I think, I've talked to many different teams, and there's lots of different ways. So this is just, some examples of where, these are maybe hints that maybe things aren't going as well as they could be. So many projects being juggled at once is actually something that's counterintuitive to many people. So if the project's taking a long time to complete and you've got many different projects on the plate at the same time, that actually highlights that the team isn't prioritizing appropriately. Because there's lots of studies that show the more projects you're doing at once, the more switching cost there is and the more challenge there is in terms of executing projects very efficiently. Another one is it's a burden to track project status. So if you feel like you're on a team, and it doesn't matter what your role is, if you feel or if others on your team feel like the process is something to be worked through as opposed to something that's helping you achieve success, that's a real sign that something's wrong, right? So if it's more about I have to do this to check a box, or I have to spend time to do this just to make somebody else happy, if you don't understand the value of what the process is asking you to do, and if you think it's just something that you kind of need to do to get something out the door, so to speak, that's a problem. And it's a problem because most likely other people feel the same way, and it's highlighting the fact that it's not adding value. It's kind of more sometimes just creating work. And so that's a really good kind of self-check that you can do. From a stakeholder perspective, and this is true whether you're a product owner or a stakeholder, or whether you're on a team and you're kind of getting feedback from stakeholders, right? So if you get feedback, if you think a project's not delivering useful insights, that's a pretty good indication that something went wrong. And typically it's not the technical side that went wrong, it's the process side. If there's a lot of discussion about not trusting the predictive model, it's like, well, that's interesting, it looks good, but there's no way I can trust what it's done. It's another indication that the process probably wasn't as good as it could be. And that led to teams not really understanding, the logic that went into building the model and why the team believes that the model is correct, and so people really don't trust it. If there's a perspective that the data science team isn't productive, a good chance that the process isn't good. Of course, there's always a chance that the team itself is not productive. I mean, the process doesn't define that the teams are going to be great. But oftentimes, teams are working very hard, but there's a perception that they're not. And then finally, this is related to some of the other ones, right? So if there's a perception that the team's not working on the highest priority items, or if you as a team member are thinking like, why am I working on this? There's this other opportunity that's much more important. It's another indication that the process isn't working the way it should, and the process is not highlighting kind of the highest value potential work items. Stated in a very high way, if it kind of feels clunky when you're trying to communicate with people, if it feels like it's frustrating to communicate people, either like too much communication, too little communication, or whatever the case might be, that's another indication that the process isn't good. And I'll throw in a little one here about the software, right? So if you're just using the same process as a software development team, and again, I came from software development, so I understand the value of those, that's another indication that you probably, people don't understand the difference between data science projects, machine learning projects, and software development projects. So the benefits of using a well-defined process, so this is true pretty much across any industry. It's in particular useful in data science because of this challenge to understand and deliver projects successfully, but also the challenge of scoping how long things take to do, right? So task estimation. So the well-defined process really helps to minimize that risk. So a good process helps teams improve their efficiency, right? So they're working on the highest priority value items. They have a repeatable process so people know their roles and know how things work. It ensures that in the end, the results are useful, or they stop the project when people understand it's not going to be useful. And again, about this usefulness, it's about making sure that the insights are actionable as opposed to just interesting insights. And that's really important. And clearly you need, great communication with stakeholders and the data science team and the machine learning team to generate that actionable insight. I'll jump to the second question here. So is there a framework that allows the data science projects that are typically data intensive to follow a kind of a smooth, agile approach that can use sprints? So, so some of you probably know what sprints are. Some of you don't. That's a great question. And what I'll say is a little bit later in this session, probably just after a break I'll give you, we're going to talk about Scrum so you'll understand what sprints are. We'll talk about the strengths and weaknesses of Scrum and the sprints. And we'll talk about maybe alternatives to that as well. So I think that's a good question. Clearly, how to think about breaking up the work is important, but I'll give you a hint that just using Scrum for sprints causes many data science teams to not like Scrum. So we've been asking questions. I'll pause here. I'll kind of give folks maybe 30 seconds to think about if they have other questions. Again, just keep putting them into the Q&A. I think that's a good way to do that. I'll answer them as I go. But this is a good time here. So I just got another question. Let's see here. Every single project is different. That is very true. Every data science project is different too, obviously. Is there a standard data science project lifecycle? So what I'll say is that we're just about to get into actually data science life cycles. And I do think it's important to have a standard data science life cycle. And there might be times where a project doesn't need a phase of that life cycle. And that's okay, but at least there's a common way to describe the steps of the data science project, and that there's a common vocabulary to say, we don't have to do this part of a typical data science project for whatever reason. Maybe we already have the data and we already worked with the client before, so we understand the business context and understand the data. It's still useful to talk about the full life cycle and explain why we don't have to do certain aspects and why we're going to focus on other aspects. Great question. And hopefully as we go through this, all three of these questions, the answers will become even more clear as I kind of dive into it more. Another question popped up here, dependency on Wizard. That's more about team cross-functional roles, right? So yeah, so I had a little statistic about being dependent on a team wizard. And so the challenge of a team wizard is a twofold. So first, and probably the most important one, is the fact that if you have a team wizard, which is kind of like an expert, right? So for those of you who maybe haven't heard that term or aren't familiar with it, it's just a really, really maybe good data scientist that just knows how to execute projects and implicitly knows how to, talk with clients, divide the work up for team members, and just get things done. And that project might even typically be successful. And the most important challenge is what happens if that person goes on vacation, leaves the team, needs to work on another project or something like that. The team is very dependent on that one person, and that's not really a scalable, maintainable solution. And the second is that no matter how good a person is, having a well-defined process will help remove barriers, remove bottlenecks, and kind of streamline communication between the appropriate team members. And so having a wizard on your team is great, but having a process leverages that wizard even more. Maybe is a different way to say that. Got another question here. When data science, which might be owned by the business, and data engineering, which might be owned by IT, are two separate teams, how is the process? So I think that's a typical challenge, is that oftentimes different groups on a data science project are not all underneath one umbrella. And in fact, when I talked about my role when I was in industry, where I had a data science team and an IT team, one part reported to me directly, and one part kind of was implicitly reporting to me, but actually reported a different chain, if you will. And I think that's where, as we get through and talk about the process, it's helpful to get everybody on board about what the process is, how it's going to work, and oftentimes like why it's different than the software process, because sometimes these teams just want to use like one process for everything. And so as we talk about the process, I think it's important to understand that independent of organizational structure, everybody needs to buy into this and understand what it is, and also help improve the process as we go forward. Another question here, data is often siloed. Yes, that's very true. It takes a lot of effort to expose the data. Yes, as we talk through the data science lifecycle that I'll get to in a minute, having a data science lifecycle helps to highlight the fact of where a project might need to spend the most time. And traditionally, it's in what maybe I'll call data preparation, right? So that's kind of collecting data, pulling data, maybe cleaning data, munging data. And that's really kind of often because data is in silos and it needs to be pulled together, if you will. And so, that's just a fact for some projects. Other projects, it's not an issue at all. But having a consistent life cycle helps make it clear to everybody about what needs to get done. And oftentimes it's very helpful to explain, even if it's just at a very high level, what % of the project each of these steps is going to take. Thank you. Those were great questions. Keep them coming, but I think I'm going to kind of go on to the next part here, which is what makes an effective team process. And why do we need this team process for data science? So before actually talking about an appropriate life cycle, again, maybe just taking a small step back and thinking through, a little bit touching on what's different about data science projects, I think maybe. And so, the first part is when I wrote here, so the project is often cloudy, lack of clear upfront requirements. My kind of example there is, it's not uncommon for data science projects to have the requirements of, we have lots of interesting data, let's do something with it. You never do that for a software project. It wouldn't be like, we have lots of people that can write code, let's do something. It's like, no, there's like, what's the problem we want to solve? And what's the system that can help solve it? And so it's different for data science, and it's different because oftentimes people just don't know what predictive value there is. And so there needs to be a process to get everybody on the same page about what we're trying to do, but also acknowledge that it's just not clear. And that's the nonlinear part about that. So that's not like this high mathematical term. That's really just meant to say that we might think that we might generate some useful insights with part of the data to fix one particular business problem, for example, or optimize something or generate more revenue a certain way. But after we start doing some exploratory work, we might identify something else that either has more value, and so we want to kind of switch directions and pivot to there. But sometimes we might just also realize that there's no predictive value in what we're trying to do. So again, we need to pivot, but not because we found something more useful, but because what we think we might be able to, what we were trying to answer, we just can't do. And so there's lots of updates as we're going through, not just like small refinements of user interface, if you will, but holistically, like what business problem are we trying to solve? What opportunity are we trying to address? And that's what I mean by a nonlinear process. So it's just that as we're using these iterations, which I mentioned about briefly and we'll talk about more, we're going to learn more. And as we learn more, we need to take that knowledge into account and not just continually go down a path. We need to take a step back and say, does it make sense to go down that path? Or does it make sense to make a right turn and do something else? Or does it make sense not to do anything at all and just stop this project? So that's what I mean by a nonlinear project. And this happens much, much more in a data science project than a software project. So benefits of agility. So agility, I'll talk about in a minute, but having these short iterations, being able to adapt as we go forward. So one key benefit is we'll have more relevant insights, right? Because we'll be able to refine what we're doing based on what we're learning. We'll be able to deliver value more quickly because we're doing these small iterations, and maybe something halfway through actually can be useful. So version 1, if you will, versus version 2. We're going to get feedback more quickly, which again helps us pivot if indeed we need to pivot. Cutting losses, same idea, right? So sometimes we pivot, and sometimes it's better just to acknowledge that this isn't going to succeed. So fail fast is a common refrain, right? So it's much better, if you're going to fail, much better to fail fast than to fail later. And if there's no predictive value in data, if the project isn't going to work, and maybe you have to kind of find something different. And again, holistically, if we have a good process, we'll have good communication. We'll be working on the right problem. We'll be knowing when to change. Everybody will be on the same page about when we should be changing. And so there'll be a better understanding of what the team is doing. And so there'll be a better understanding of how productive the team is, as opposed to just, well, like they just did some work. I don't understand what work they did, and now they're telling me there's nothing value of it, right? So if we have good communications, everyone's on the same page about what work is being done, how productive the team is, and why we're pivoting or why we're not pivoting. It's not just, product owners trusting the data science team. It's product owners part of the data science team. So here is like maybe one of the key fundamentals. If you only take away a few things from this entire talk, and this slide is probably one of the most important things. It's what do I think is the most important aspect of having an agile data science team. And again, you need this agility to work through these issues of it's hard to understand how long things will take. It's hard to know if we're going to have predictive value, things like that. So the first thing is to use iterations. If people know Scrum, that's known as a sprint. But an iteration is a small burst of work just to learn something and then figure out what to do next. And again, for using iterations, the next key thing is to have them be small. And they're small because we want to learn from that and figure out what to do next. So the bigger iteration is, the more work we need to do before we can adapt and go forward. So the goal always should be as small as possible. And we'll talk a little bit more about what that means in a little bit. But conceptually, you want to do small iterations. And the last part is, the most important part that sometimes gets overlooked. I think people in generally kind of understand the value of iterations, understand the value of keeping them small, even if it's hard to understand what small should be. It's the last part that often gets skipped, which is the key aspect. So we need to get feedback on each iteration. We need to talk about the results of each iteration. The results could be any type of learning, right? So it doesn't have to be an output of a predictive model, but we might be looking at how good data quality is from a certain data feed, for example. That could be an iteration. And the results will be talking about the data quality from that feed. But it's really important to discuss the results with stakeholders so they understand it and we can collectively figure out what to do next. So you can kind of think about this as being a loop, right? So we're going to do small iterations, we're going to get feedback, and then we're going to kind of figure out what to do next. And in my mind, no matter what framework we're using, this really helps minimize risk and drive up success. So there was a question here, it's a good one, right? So do we need to cover the entire data science lifecycle in each iteration? So it depends a little bit on how the team is working. The short answer I'll say is no. There certainly are frameworks that kind of suggest you should, but from my perspective, no. I think the project is going to need to at least address all the different aspects of the lifecycle. But as we're doing one iteration could be solely focused on data cleaning, for example. That'd be a fine iteration. And so an iteration itself needs to have something that's measurable at the end, like what are we going to learn from that iteration? And it needs to be clear where we are in the life cycle. But I personally don't think that we need to cover every single aspect of the life cycle. Thanks for that question. So I'm going to talk a little bit about the Agile Manifesto. So there's a URL you can see there. It's been around for well over 20 years now. And it was first done for software, but Agile approaches and even Scrum are used in many different industries. And so again, I think when we think about agility, it's kind of good to go back to the roots and think about things. So the first one is individuals and interactions over process and tools, right? Because it's the people, it's making sure that there's an interaction. It's not just having some tool that you kind of interact with. It's not just trusting the process, it's the people. You need a process to streamline communication and make sure things are going effectively. So it's not to say process is not important, but process is not the goal. Process is a facilitator, which is why I said at the beginning, if you think process is like a hoop to jump through, that's a bad sign. The next part is working software over comprehensive documentation. We can adapt that a little bit in a data science context, but basically we want something that's useful from a coding perspective, from a data perspective, as opposed to something that's just very well documented. Collaboration versus negotiation. This is key. This is probably more key in data science than almost any other field. And that's because of this nonlinear approach where we might have to pivot. And so it needs to be collectively understood what we're doing, why we might change. And it doesn't mean there can't be a contract between, a vendor and a client in terms of building a data science project. You can certainly do that, but it still needs to be a collaborative approach about what we're doing and why. And then finally, again, about this nonlinear approach, we really need to be able to kind of just mentally think that we're going to respond to change versus following a predefined plan that we defined at the start of the project. So as you can see, the key concepts of agility as defined by the Agile Manifesto many, many years ago, I think totally makes sense for data science. And keep in mind, the Agile Manifesto is not Scrum. Scrum is an implementation of how to be agile, but it's just an implementation. See some questions here. Let me kind of jump in and kind of answer some of these. Let's see here. So first one was, how long should an iteration be? And the question was like 1 week. And yeah, so my goal would be to have an iteration be typically a week. And what I'll talk about in a little bit is, again, because it's not clear how long things take, because in data science, oftentimes it's hard to scope things out. That's a very broad view. So it might take 4 days one time, it might take 2 weeks. But you want to have something in that goal, that range, if you will. Somebody just noted 69% of the team working on the wrong problem. Yeah, that's not good, right? Yeah, sorry. Let's see, the importance of well-defined process. So I get the question. The question really, I think, has to do with, so if we have a well-defined process, how does that relate to this thing about individuals and interactions over process and tools? So I think that's a good question. And I think what we want to think about is, Agile Manifesto doesn't say you shouldn't have a process. What it says is the process should not be driving the interactions. It should be facilitating the interactions. It should be almost, if you want, subservient to kind of support what's going on, as opposed to people just kind of working through a process to check boxes, because checking the boxes won't ensure the team's working on the correct things. Checking the boxes of a process, and I've, over the years worked on teams that have had this, it just turns into a labor exercise that doesn't really add any value. So you want a well-defined process, but you want to make sure that that process is encouraging individuals and interactions and is facilitating that, and is providing a framework so it's much easier to make sure that we're talking to the stakeholders appropriately, as opposed to you have this process that kind of feels very heavyweight, that kind of even, in some sense, even blocks the interactions with other individuals. Let's see. How would you prioritize co-location for DS customer collaboration? Okay, so yeah, so location, I think we can talk about that a little bit, but I would say that, first of all, an effective process facilitates teams being in different locations. So that's one thought. Second thought I have is that the truth is now, post-COVID, most teams have some virtual component. And I think there's many different ways to think about how to manage through teams that are not co-located. But I think it's just an everyday reality. And I think that's another situation where a process facilitates making that work effectively. Because you can't just kind of walk over and ask somebody, but you want to make the structure of the team such that people easily interact, whether it's through Zoom or whatever the case might be. So I'll definitely talk about how to address the working on the wrong problem part. That's another question. I'll address that in a little bit as we talk about iterations, for example. So let's see here. So we've talked about Agile Manifesto. We've talked about the fact that it was actually called the Agile Manifesto for Software Development. But in fact, I do think it makes sense for data science. It makes total sense for data science. But if you notice, the Agile Manifesto talks nothing about a life cycle, right? It doesn't. So let's kind of start to drill into that maybe just a little bit more and talk about, like, if we need a good process, why maybe is a software process possibly appropriate or not appropriate. And I thought it would be useful just to take a minute or two to think about the difference between a software project and a data science project, a project that's using machine learning. And I've kind of implicitly talked about that for many different things. And obviously, in fact, the statistics about project failure is way higher for data science than software teams, right? So 69% of software development teams are certainly not working on it, right? So they definitely are working on the problem much more frequently. And so let's talk a couple of them. So the first area that I think is a key difference is this exploratory focus. Even for a project that wants to be put into production, has like a 4-month timeline, there's still a lot more typically exploratory analysis that needs to be done, ambiguous requirements. Will the data have predictive value? Will the data be clean enough to generate predictions? How easy will it be to get the data? You don't have those types of questions oftentimes in a traditional software project. And I also think just in general, it's harder to manage expectations of clients and stakeholders. And there's many reasons for that, but I think one of them is just people are newer to working on data projects than they are on software projects. So people have a better intuitive understanding how a software project works. This is whether they're technical or not. If they've kind of worked on being kind of a stakeholder in previous software projects, they kind of have a pretty good sense of it. But for data science, that's really not true. A lot of people, this is their first or second one, they're not really sure how it's working. They're not really sure why it's different than a software project. And so it's much more challenging to make sure expectations are appropriate, right? So, and again, if we have a good communication, that can really help. I've talked about data challenges. I've talked about that there might be, areas where we have to do a lot of data cleaning. There might be things like that. So those challenges are typically much more pronounced in a data science project, machine learning project, than they would be in a typical software project. Even if that software project has a large database component of it, oftentimes it's because the software project is generating data that's going into the database, for example, or it's reading a well-defined database and presenting it out in different things. And equally important, lots of unknown outcomes, right? So the very simple thing of how do you validate that the predictive algorithm is correct versus how do you validate a software system is correct is very different. It's much, much more challenging for a data science team to validate that what they've built is actually correct. What does it mean to be correct when the model is making a prediction of 85% or 65% versus a software system that just should always work correctly? And then I mentioned ethics a little bit ago, and I'm not going to spend a lot of time on it, but I will say that there's far more ambiguous and challenging ethical situations that might arise in terms of making sure that models aren't biased, for example, against some segments. Different aspects of that also generate different challenges that need to be thought through throughout the entire project as opposed to maybe just at the end. And so these are some of the differences. We could talk for a lot more about what these differences are and other differences are. But I think even looking at success rate of data science projects versus success rate of software projects, the challenges that data science teams report versus the challenges that software teams report, the challenges of stakeholders and product owners in data science versus software projects, all lead to the fact that there's something different about data science projects, about building predictive models. And because there's something different about those projects inherently, it suggests that the issue isn't just that data science teams need to adopt what software teams use. It's that they're different. So maybe the frameworks need to be slightly different, more different, but we just shouldn't blindly use what software teams use because they have different challenges and therefore maybe a different process would be more appropriate. So now I want to start drilling into how do we actually think about an effective process? And so I can kind of think of 4 key components, but really the first 2 are maybe the most important. So I've talked about a data science lifecycle. Some people actually use the word workflow. I'm fine with either. There's subtle differences. I don't really care. But I think it's really important that the team collectively defines the steps of a data science project. The other part is there needs to be a way to have agile collaboration and communication. How does a team communicate effectively across the team? How do they figure out what to do next? So these are 2 different aspects. of an effective process, and you need both. Then other aspects, which I won't spend nearly as much time on, but I'll touch on just a little bit, is we need model management. How do we keep track of the models we have? How do we keep track of the knowledge we're generating? What tools are approaching? And finally, how do we improve our process? How do we understand our process? So no matter what process you have, you can improve it. I don't care how good or bad you are, you can definitely improve it. And if you only take out one thing from a process improvement perspective, it's your team should have some way to, on a regular basis, take a look at what the team is doing and how we can improve it. So rather than just assuming whatever even if you took a step back and said, let's redefine our process, that still won't be perfect no matter what you implement. And if you can't do that, and there's lots of reasons why you can't, having a mentality collectively that we want to improve our process, and we're going to take some time to think about how to do that, is really important. So these are the key dimensions I think about of how to achieve an effective process. And I'll drill into these. So as I said, the two key aspects are the workflow or lifecycle, and then the collaboration framework. And I just want to drill into a little bit more about what a workflow is, or the data science lifecycle. And that's the steps that the team does. So some steps might be obtain data, clean data, create a predictive model. And what this does is it creates the shared vocabulary of the work to be done. And the shared vocabulary is important not for the data scientists. For the data scientists on this call, you intuitively know the steps to do. But for the others, maybe you don't. And equally important, maybe you do, but if you hear two words that are similar, you might not be clear about, is that the same part of the life cycle? Is that something different? So having a consistent vocabulary doesn't help data scientists because they kind of know what to do, but it helps communicating with others. It helps them understand the steps of a project and kind of removes communication when a new term gets thrown in there that's, is cleaning data the same thing as munging data, is the same thing as, loading data, right? So you just need to have a consistent vocabulary. Everybody gets on the same page. It's really helpful. The other part is this collaboration or coordination framework. And that's important to help prioritize tasks, right? So data science lifecycle doesn't tell people what the priority of a certain task is. So you need some way to talk to other people to figure out which tasks are most important, to figure out when to pivot, do things like that. And that's where this collaboration framework is really helpful to help sit down and make sure people are actually sitting down, I guess is the best way to say that, to think about what makes sense. I'll drill into both of these in a lot more detail. So first, I'm going to ask another poll here. And so this poll, I'm just trying to get a quick understanding of if you've heard of any of these. It's totally fine if you've heard of none. You can leave it blank. I didn't put none in here, but you can leave it blank. Or if you've heard of some. And, and from heard, I mean, you've heard it used in conversations outside of this discussion, right? So if you read, an introduction to this session and that's where you saw it, I would leave it blank. But I'm kind of curious if you've heard of any of these, and I'm going to get a quick, so I'm going to give you a little bit of time. So the choices here, right? So CRISP-DM, which is data science lifecycle, TSP, which is a different data science lifecycle. SEM is a lifecycle for data projects, not particularly for data science. Scrum I've talked about is really a software-focused agile coordination framework. It's used in many other fields. Some teams try to use it for Scrum. It's a way to implement the Agile Manifesto. Data-driven Scrum is a version of Scrum that it's different from Scrum, but it's similar to Scrum, but it works specifically designed for data-driven projects. And then Kanban is a way for teams to be lean, and I'll talk a little bit about that, but there's different ones. And so we're getting some votes. I'm going to give folks another, few seconds to kind of, enter their votes, and then we'll just see where things are at. Okay, let's take a look. So about a quarter of the people have heard of CRISP-DM. Almost everybody's heard of Scrum, and everybody has heard of Kanban. So that's pretty interesting. I think it's a very useful notion, and I think it depends on your background too. And what I mean by that is data scientists have one perspective, and it really depends on what the organization is. So a lot of people presented different things. So I think this is very helpful, and the fact that everybody's heard of Kanban and most people have heard of Scrum, I think that's pretty interesting. Here's a question, and I'll Take a look at that, taking into consideration team topologies as well as structuring. So yeah, I'll talk a little bit about how to structure data science projects, and I'll talk a little bit about that from a remote perspective. But I think some of that depends on the project, but I'll dive into that a little bit as we talk into team roles, for example. We've been having questions throughout. I think this is a good chance to pause just to see if there's other questions. And if not, I'm going to jump into data science life cycles and in particular CRISP-DM. But I'll pause here for a second or two so people can kind of think through. And if I've missed a question, you can certainly repost it and I'll take a look at it again, but I try to keep an eye on it. All right, let's go to the next chunk here. So I want to talk about CRISP-DM and data science lifecycles. So first, I want to review what a data science lifecycle is, just to make sure we're all on the same page. So it creates a common vocabulary of the steps in a data science project, right? So it defines the step-by-step process needed to do a project. The goal is to create a shared mental model of the steps to be done and a shared vocabulary of the steps to be done. So again, if you're a data scientist, you kind of know this and you can write it down. But if I ask two different data scientists, they might use slightly different words. And that's why we want something that's consistent. And we want something that kind of makes sense in your organizational context. So it's important to have one. It's not so important which one it is. So why am I going to talk about CRISP-DM? And that's because from a data science lifecycle perspective, CRISP-DM is by far the most commonly used or commonly known data science lifecycle. So the others I mentioned, for example, is TDSP and SEMA, like that didn't get any votes really. So CRISP-DM is somewhat well known. It's very old, and I'll go into that in a little bit. But that's where we're going to focus on that. And then, as you can see here, some people use Scrum and Kanban, but those are different. That's a collaboration framework. So I want to kind of drill into how much people have heard about CRISP-DM before I go further. So never heard about it before today. And again, think of today as being when you read about this presentation and this discussion. Heard about it, but just heard about it in passing. Didn't even really know what it was. You knew about it, and maybe you kind of knew about what the life cycle phases were, and that maybe you even used them. And then finally, the D option here is you've used the entire framework. So I'm kind of curious about this again, and if you didn't vote before, this is your chance to kind of click that never heard of it before today. So I'll kind of pause a little bit and I want to get a feel for kind of the knowledge about this. And again, typically if people have heard of anything, it's CRISP-DM, and we'll go over what it is, but I'm going to pause here just for a second or two, try to get a good view of kind of the knowledge that folks have of CRISP-DM. And while we're doing that, I'll tell you that CRISP-DM, it's old, just like Scrum. Scrum is old. Both of these have been around for over 20 years, developed in the 1990s. So I guess it's close to 25 years for both. Well before data science was really a defined field. So let's take a look now at the breakdown of what people have heard. We've gotten a pretty good chunk of votes in, so let's take a look. So 2/3 have never heard of it. And again, a quarter of the people have heard of it, but really didn't know what it was. And so a very small percentage of people have actually used the entire framework. And I'll go through and explain the entire framework, and even that 7%, we'll see whether you actually use the entire framework or maybe just a subset of it. So let's kind of drill into it. I think that's kind of interesting and not too surprising, quite honestly. I think a good chunk of people have heard about it, but many have not really used it. So this is a very common picture, or a picture is very similar to this that kind of explain CRISP-DM. Here you can see what it stands for, Cross-Industry Standard Process for Data Mining. Again, it was defined in the 1990s before data science was a field, and it was really obviously to generate insights from data still, even if data science wasn't specific. And it describes 6 key iterative phases, so I'll go through each of these phases in a minute. Each phase has its own defined tasks and set of deliverables, including reports. And I think that's the part that often gets missed when people say that they're using CRISP-DM. And you can see here that the project can loop back as needed. So what I mean by that is that the project can go from data preparation back to data understanding, or from modeling back to to preparation in a phase like that. So you can go from data understanding back to business understanding. You can go from evaluation to business understanding. So there's lots of different ways to move back and forth. And I would even say the standard really enables you to go back and forth even more than these arrows go. So, for example, there's not an arrow going back and forth between evaluation and modeling, but the standard really lets you kind of do that one as well. So important, what's not defined as part of CRISP-DM. So roles on a team are not defined. How to prioritize what to do is not defined. How to go to the next step is implicitly defined in kind of this documentation and reports, but there's no real way to talk about that. So let me kind of start to drill into it. So I mentioned, the reports at the end of each phase. And so here's a page straight out of the standard that's been published. And this is the part that I think most people, even that 7% that's on the call right now that said that they've used CRISP-DM, I'm going to guess the full 7% haven't generated all these reports. And I think that's probably pretty reasonable not to do that. But this is the CRISP-DM standard. So it talks about what should be done at the end of each phase. And that's helpful. It kind of gives you a better understanding of what to do at each phase. But again, if we want to be agile, we don't want to kind of go in a very waterfall model, do full business understanding, full data understanding, full data preparation, then modeling, because we want to learn as we go. We certainly don't want to document everything at one phase before we even start the next phase. So there's some iteration that can happen here, and we can talk through that. But it's a key to think through that the actual standard does talk about kind of outputs at the end of each phase. So let me drill in just a little bit each of these phases, especially the folks that aren't focused on data science. This might be helpful to give you an intuitive understanding of the process. And the other data science life cycles might have slightly different words, might focus on different things, but I think at a high level, CRISP-DM is useful, and that's why even after all these years, it's still pretty well understood and used. So business understanding, I think the goal here is just to make sure that everybody understands what the goal of the project is, right? So what's the situation? How will it be used? What's the objectives from a business perspective? And what's the plan, if you will, to implement something? So it kind of makes sure that the technical team, if you will, understands what the product owner, what the stakeholders need is one way to think about it. Then data understanding. So this is something that's a little bit more specific to the data science projects as opposed to software projects, which is what data is out there? How might it be stored? What is the expected data quality? And quality in terms of noise in the data, quality in terms of how much data is there, is it 1 year, 5 years, things like that. And how do we describe the data? And other data resources that might be useful. So oftentimes there's other public repositories of, maybe weather data that might be useful if you're trying to do certain predictions. And so it's understanding what data is available in the organization, but also what data might be available outside the organization that the team can legally access and use as part of the predictive model. That's all part of data understanding. Then we get into data preparation. This is the part that I mentioned before that often takes 50, 60, 70% of the time. It's where you pull everything together. So you're going to select data from maybe different repositories. You're going to merge data together. You're going to clean and format that. You might do something known as feature engineering, which takes data attributes and maybe creates something that might be more interesting or more useful for a machine learning algorithm or for a person to understand. So for example, for age, rather than having it be a number, you might have child, teenager, adult, senior citizen, or something like that. That's a very simple example, because the difference between maybe somebody 50 and 51 is not that large, but you still have these different kind of larger buckets. And so you might do feature engineering. And there's all this work that's required to make sure that you have this data that's available to be fed to a machine learning model. Next, we're actually going to do modeling, generate a predictive model. Obviously, the team needs to think about what type of models might be useful, how to tune it. What do we think about accuracy? How do we define what a good model is? Are false positives and false negatives equally important, for example, to minimize? Or is one much worse than the other? Those are the types of questions that people ask when they're building modeling. I mentioned ethics, obviously, in modeling, in data prep, making sure that the data itself won't lead to bias. Biased data generates biased models. So, between data prep, data understanding, and modeling, ethics kind of permeates all of that. So evaluation is really about how good the model is. And this is how good the model is from a business context perspective. This is where it's important that we start talking about the model accuracy. Again, false positives, false negatives, understanding what we expect, and then is that useful? And it depends on the context, right? So a marketing application needs lower accuracy, lower kind of model validity than something that's going to be used in healthcare, for example, oftentimes. And so it depends on the context, depends on the organization, depends on the cost of mistakes. No model is going to be perfect. If you got a perfect model, that means your model's really bad. Actually, it means it's probably memorized something that's not going to be useful going forward. So it's always thinking through, how do we know it? How do we explore it? How do we think about it being good? And if you remember, a while ago I talked about it's hard to do, quality assurance, to do testing. And that's part of evaluation, because you don't just know if it's right or not. You have to kind of think through different scenarios, understanding how accurate the model is. And again, understanding it's not 100%. And finally, deployment. So deployment means many different things depending on the context of the project. It could be just a report. It could be an interactive dashboard. It could be a predictive model that's deployed live. And all of those require different types of work and support. And oftentimes, I have here monitoring, right? So depending on the type of system, monitoring could be very important. And then based on that, the team needs to learn and perhaps go forward and generate, other insights, maybe generate new models or whatever the case might be. So these are the kind of the key 6 steps of a project. Oftentimes people do talk about monitoring and measurement as being separate from deployment, just to make it clear, but other times they don't. I got a question here. Let me read through this here. So regarding data understanding in a large organization, that includes effort to get a reliable, secure feeds. Yes, so that's definitely a part of both data understanding and data preparation. So what I would say is data understanding is to understand where that data is, maybe in a certain silo, and identifying it, right? So siloed, sometimes it's a little challenging even to identify what data might be useful. Data understanding is understanding where those silos are, understanding, if you will, the format and structure of the data warehouse, or whatever the case might be. And then the data prep is the other half of that, which is actually being able to pull that data, being able to get a reliable feed. And what came across there, sometimes approvals, let alone technical issues, but just logistically getting an approval can take an unknown amount of time. It might take hours, days, and sometimes even weeks. And so that just is a great example of how task estimation, how long something will take, is